Hello, welcome to the video series on quality management and analytics. In this brief video, I'm going to show you how to perform a hypothesis test in Minitab. Mahindra Engineering Solutions is a company specialized in manufacturing of medical devices. And we're going to use the case and the practice files from the book Project Management Across Industries, a case-based approach, to perform this test. Now, as you can see, if you can see my screen, I have data for my test. Mahindra Engineering Solutions implemented an AI-powered manufacturing system, and they'd like to know whether there's a difference in the mean of the process variations, before AI and after AI. Obviously, this is an expensive investment. It's a good idea to know whether it's worth it. And a good way to do that is to use data and statistics. So for this test, we're going to, because we have two samples, we're going to perform what we call a two-sample t-test. Now, if you see my screen, click on, if you can do this with me, click on Start, Basic Statistics, and two-sample t. As you can see, a one-sample t is when you have one sample and want to compare your sample with a target value. For example, a process mean. A two-sample t-test here means I have two samples and I want to determine whether there is a significant difference between the mean of the samples. Now, click on this here. Now I'm going to make sure that this is empty, so there is no confusion. So the way your data is presented is extremely important to tell Minitab that, because it wouldn't know automatically. This is the default. Both samples are in one column, which is the case for us, right? Now, for the samples are in this column C2, right? I'm going to select it and click select. And the sample IDs are in column C3T. The T is for text. I'm going to select it and do this. Now, if I click OK, it will perform the test and give me a p-value or probability value. It's going to explain in a minute. But I want to use graphical analysis to give me a better idea of spread and other characteristics of my data. So we can click on graphs, and we're going to include the individual value plot. If this isn't checked, you should check the boxes here. So I want the individual value plot, and I want also the box plot. So I'm going to click OK. And I click OK again. And as you can see here, this is my result. Okay. Okay, perfect. So I have descriptive statistics. I have the means or averages of my sample. You can see here there is a drop in the mean of the process after AI implementations. This is before and after. And there is also a decrease in variation, which is fantastic, which is what all manufacturers are looking for. And if you look here, we have standard error of the mean. Now, SE mean, that's standard error of the mean. This shows how accurately we estimate the average, and smaller values mean higher precisions. Now, this is important. Now, other thing to look at is the 90% confidence interval that we set for our tests. It means that we are 95% confident that AI reduced defect rate by between 2.45 and 5.13 defects per thousand units. So this interval is based on the mean difference, which we call point estimate, and it is plus or minus the margin of error. Now, I'm not trying to turn you into statistician here. What I'm trying to do is to make sure you understand what it means, the result of all this. Now, bear with me. Take a look at your t-value, right, and degrees of freedom, df, that's degrees of freedom. The t-value was the t-value is 5.82, which means that the observed improvement is over 5 standard errors away from random chance. This is pretty significant. Now, degrees of freedom, it means the test used 26 degrees of freedom, which account for the sample size and variability. Remember, we had 2 samples, 15 data points in each samples, that 30, and you have degrees of freedom of 26, which means took variability into considerations. Now, what are the what's an important statistic here is the p-value, the probability value. Now, the probability value is less than 0.0001, which shows the improvement that we're observing is statistically significant and not due to chance. Now, what is important to remember is that a low p-value doesn't prove the observed difference is real. It just tells you that such a difference would be very unlikely if there were no real effect. So that's what you're looking at here. Now, the last thing we have to look at is how useful, you see, visuals are, the individual value plot and the box plot. As you can see, visibly, there is a difference between the mean here, drop, a significant drop, and actually it is measured here at 3.794, which is the difference between the two means. And you can say, looking at the plot, that which illustrate reduced median and spread in defect rates, which confirms better quality control with an AI-powered system. So that's fantastic. Now, so what we did in this video, we conducted two sample tests, t-tests, to determine whether there was a significant difference between the AI-powered process and before, on the non-AI-powered process. And we concluded, based on the probability value and the other statistics we talk about here, decrease in variations, and that there is actually a significant difference between the two. So AI implementations made a difference. So thank you for watching this video. If you have any questions, please feel free to reach out to me, and I'll be happy to respond as soon as I can. So subscribe to the channel to receive alerts when new videos are posted. Thank you very much.